All right, this is Unit 5, Lesson 3, Part 2. We're going to be talking specifically about all these different characteristics of a polynomial function, just practicing them again, and then you guys are going to be working in groups and coming up and describing all of these characteristics that you can see. So it's going to begin by just looking at the graph on Desmos, which is exactly what we did in the first part of this lesson. So I've got this pulled up here. I am going to plug in the equation for you. So if you want to follow along, just to play around with Desmos and make sure you're comfortable, I would suggest it. All right, so I've got this equation typed in. I'm going to get the equation itself out of the way, make it bolder a little bit. There, so that is our equation. Remember, you want to plot that yourself. So if you just tap on Desmos, it'll give you an idea of all of the important points that you should put on there. So got this one right here, so negative 4, 0. I'm going to plot that. So 1, 2, 3, 4. This one right here up at the top, not exactly the prettiest numbers, but it looks like it's a little bit, like basically negative 3, 3, but like a little bit past. So negative 3, 3 would be right here. So like a little bit, kind of just in the corner of that box rather than like right on the grid. Right here, we've got negative 2, 0, right on the x-axis. So that point is right here. This point right here, we've got negative 0.85, so like almost negative 1, and then a little bit past negative 3. So almost negative 1 and a little bit past negative 3 would be like in this corner right here. So not quite right on the grid. And then right at the origin, 0, 0. So we've got these points right here. So I'm going to sketch in, just make it look as much like the Desmos graph as you can. Goes up forever here, down forever here. So that's our grid. Now we're going to write everything that we can about it. Okay, so we've got our turning points. So these points, I'm actually going to label these strange points right here. So this one was a negative 0.845, comma, negative 3.079. And then the one up at the top here was negative 3.155, comma, 3.079. So that way we can talk about them because we'll need them for the turning points, the increasing and the decreasing intervals. And then these are just right on the axis exactly where they look like they are. So I'm not going to label those. All right, so our turning points. Turning points, this point right here, it's going up and then it turns around. That's what we mean by turning points. And then it goes back down. So this turning point, we can label it as negative 3.155, comma, 3.079, and that is a relative max. So you always want to be specific about which type of turning point it is. And then this one right here, we can write down that point because it's going down and then it turns around and starts going back up, meaning it's another turning point. So negative 0.845, comma, negative 3.079. And this one is like a little valley in the graph, so that is called a relative min. You don't want to just identify them as turning points without saying which type, either a relative max or a relative min. All right, let's write down over here our parent function. So for our parent function, you're basically just looking at the degree. And the degree here, the highest exponent is a 3. So our parent function is just the original cubic function, which is just x cubed. And then obviously lots of transformations have happened, but this is the parent function, which means you can use the parent function to come up with the end behavior. So remember, an odd parent function means that the ends should be going in opposite directions. So we can use that to fill in the blank here. So this end behavior, it's usually filled out for you, but we normally start off with this and this. So we always have one of each of these. You're always going to have x approaches positive infinity and x approaches negative infinity because that describes the two ends of the graph. So as x approaches positive infinity, that means that x's are getting bigger, which means that x's are going to the right. So this is always describing the right end of the graph. So on the right end, the arrow that's going to the right is also going up. So this arrow, it's like never just going up or just going to the right. It's always kind of a diagonal. So it's doing two things. This one is going up and to the right. So as our graph goes to the right, the function values go up. So we say f of x approaches, positive infinity. So this is as the graph goes to the right, the function values go up. That is essentially what this means. And then we can look at the opposite end. So this is saying as x goes to the left, so we look at the left arrow, which is this guy right here. This arrow is not just going left, it's going left and down. So we say the function values approach negative infinity, because that's what means the function is going down. So right and up, left and down. That's these two arrows that you can see here. All right, let's keep working our way around here. Let's bounce over here. There's no real particular order we have to do this in. Increasing intervals. So whenever our graph is going up, so it goes up this whole piece of the graph right here. And remember, with intervals, we write intervals of x values. So starting with this x value, ending with this x value. So the x values don't really start because we have an arrow right here. And remember, the left arrow, we consider that to be an x value of negative infinity. So at the x value of negative infinity is where we start to increase, which is where our left arrow is. So the increase goes, it goes, it goes until it hits this point, and this point has this x value. So we say it increases from the left arrow until it hits this x value, and then it's going to increase again, because then it decreases here, but then it switches back around and it starts increasing again. So it increases starting at this x value, and then it goes on forever with an arrow on the right. So if we have an arrow on the right, we end it with a positive infinity. So these are x coordinates, where the x's stop and where the where the x's start and where the x's stop. So it starts to increase here, and then it stops when it gets to this x value. It starts to increase again here, and then, it doesn't really stop or start, but this just means it doesn't stop. It just keeps going on forever to the right. This means it doesn't really start, it just came all the way from the left-hand side. So then for our decreasing, it decreases right in the middle here. It's always easier when there are no arrows involved, because it starts decreasing at this x value and it stops decreasing at this x value. So our parentheses, we write the starting x value, comma, and then the ending x value. So this is saying every x value from here to here, the function is decreasing, which is true. All right, domain and range. Domain for every polynomial ever is all reals. So we don't even have to think too hard about that. Everything that you're writing today will be all reals. And then the range might be all reals, or it might be like less than a certain value or greater than a certain value. If it's an odd function, it's going to be all reals, because an odd function always has one arrow going down and one arrow going up, which means it covers everything. So if it is an odd function, the range is going to be all reals. If it's an even function, it's not, because an even function will either have a maximum point or a minimum point. So you'd have to be more specific about the range. And finally, our zeros. Zeros, remember, are x-intercepts. So we write x equals, do our little curly brackets, and then let's look from left to right here. Here's our first one. That is an x value of -4. We knew that when we plotted it. Then keep going. This x value is our next one. That's a value of -2. And here's our third one. That's an x value of 0. So 3 different x-intercepts, 3 different zeros. Remember, what zeros mean is that if we were to plug any of these values in here, we would get 0. It's like if you look at -2, for instance. -2 cubed is a -8, plus 6 times -2 squared. So when I square this, I get 4 times 6 would be 24. So we have -8 plus 24, and then plus 8 times -2 is -16. So -8 plus 24 plus -16 does end up giving us 0. And you could get the same thing from a -4. The 0 is pretty easy. If we plug in 0 here, here, and here, it's obviously just 0. So that's what this definition actually means. So you guys will be doing something very similar to this during class.